Hello, today I will show something about information gain in decision trees. I will talk about information gain, entropy, and all related topics. If you go to the web page of information gain in Wikipedia, there are a lot of formulas. So it is somewhat intimidating to see all these formulas. But today it is my intention to sort out lot of things and to make it very easy. So I will start first with what is a decision tree. Suppose we have a table where we have outlook, temperature, humidity, and windy as our attributes or columns. And this is our target column or the column where we want to make predictions like play golf. It means I want to make decision whether I can play golf given these parameters of whether it is rainy or hot or high humidity or windy, and depending on this I will predict whether I can play golf or not. To to create a decision tree, first outlook, that is this column, is selected with sunny, overcast and rainy as its parameters, and then I divide it again and again depending on other criteria and come to the conclusion that whether I can play golf or not. The main issue here is how can I choose this outlook as my top column where I split my tree or decision. To get to this point, the calculation is based on information gain and entropy. So I will go to that topic. So to create that example, I created a Excel sheet with three attributes and one target. Suppose I'm running a company bank and I'm giving loan for purchase of a car or something, and I want to make sure that the person who is taking loan will default on that loan or not. And to come to that conclusion, I have this information, which is whether the person is married or not, whether the person is own the house or rent the house, and whether person is employed or unemployed. And depending on these criteria, I make sure or I try to predict that the person will default or not. So to make get that criteria, I have uh, classified this into uh, this count, and I got this count from this simple SQL. So this is for the column of whether person owns house or rent the house. So these are very simple SQL statements, and from these statements we can get these type of numbers. These statements become helpful if our database is large, so that we cannot count by manually. So once I get these numbers for each column from SQL, I go to this structure. So this is for house, this is for employment, and this is for marital status. I will go through these columns. These are arbitrary. First, I will go to this column. Uh, this is very extreme case. It means that if the person is employed, he will default, and if the person is unemployed, he will not default. And out of 20 cases or 20 rows of our data, all data is divided, and we can say clear cut that there is very easy thing to predict. If the person is employed, then the default is yes. So this is very simple thing. We get almost all information about whether the person will default or not from this single attribute. This is a case of another extreme. So if we know the person is married or unmarried and whether he will default or not, it is equally divided. So it's just not possible to predict anything depending on whether the person is married or not. and he will default or not. So this is typically a useless column. That is, information is zero. We don't get any information from this to predict whether person will default or not. This is the case which is lies in between these two extremes, where we get a little bit information whether person owns house, then he will not default mostly, and if he's rented, he will default. So depending on this column, we can get a little bit information. So for conclusion, we can say that all information is gained from this attribute. Zero information is gained from this marital status attribute, and little bit information is gained from this house attribute. So without touching a single equation, we just can come to conclusion, and we can choose this attribute for our decision tree. Uh, so for this decision tree, this outlook type is the first dividing is chosen depending on what happens here. The If the attribute is giving maximum information gain, then we choose that attribute to divide our tree. Once that tree is divided, then again for another choose of that attribute, we do same thing and choose the column with maximum information gain. So now we will go to R code to show how to calculate that thing. So to get the idea of what is entropy, I created this small code, and I will show first what is entropy. So this is a mixture of group. Suppose this is X value and this is Y value. Means suppose we are talking about marital status. So green dot is married and plus sign is unmarried. And in this group, it is combined. So it is a impure group or it is a mixture group. When it is a mixture group, the both are combined together. There is no purity or it is more impure. With only one value dominating, it is less impure or more pure, and this is maximum pure or totally pure because there is no impurity. So depending on this, we uh, can get to the formula. So to know the entropy, entropy means impurity, simply speaking. So just replace entropy with impurity, it will make matter easy. So I created uh, this table. These are first few rows of the created table where I created x value, y value. The x value goes from 0 to 50. Y values goes in reverse order from 50 to 0. Then I get proportion, that is out of 50, 0 is x. So it is x proportion is 0, y proportion is 1 or 100%. And I calculated for all these 50 values entropy by the formula. This is the formula you can get in any statistics book or on Wikipedia. It is not that complicated. It is we multiply with that proportion by logarithmic of that proportion plus means summation of everything, and then we make it negation at end of that formula. So this is the formula we use for calculating entropy. I calculated entropy for all values or 50 rows, and then I created a graph. So from this graph, we can see that if there is only one type of instances in that particular mixture, means only X are present, then the entropy is zero. This is entropy. And if the mixture is combined, that is 50-50 mixture, then it is most impure group or entropy is 1, that is maximum entropy. Once we get clear about the idea about entropy or impurity, then rest of the matter is very easy. I loaded this table, which I shown before, into R with these first 5 or 6 rows we can see. Then to calculate entropy, I created a simple function whether we get A and B, that is a proportion of two values, and then I can return directly what is entropy. So to calculate information gain of a particular table, what we do is we first calculate entropy of parent. Parent means we don't consider any attribute. We consider total table as such. So to get this default column and count yes and no. So there are 10 yes and 10 no. So this is very impure group, impure or having high entropy. We can see that from the code also. So entropy of the parent, that is 10A and 10B, that is a 10 instances of one type and 10 instances of second type, that is 10 yes and 10 no are there in our table for target. So the entropy is 1, that is maximum impure. To calculate entropy of each attribute, we get average of entropies of all uh, that subclassification. So we can first look at entropy of marital status attribute. In marital status, we have division like this. So from the formula, you can get the formula from statistics book. I'm not going through formula because I want to make matter simple here. So we calculate entropy of the marital status attribute. It is the entropy is 1. It is as it is admixture. That is it is impure. It is mixed together. The entropy is 1. That is it is maximum impure group. Then we calculate entropy of attribute housing or whether person owns house or no. We get little bit information from this house, that is 8. That is if the person is renting house, then it is more chance that the person will default. So we get little bit information, but entropy of this house is 0.72, and entropy of the attribute employed, that is the third column, employed. So we get maximum information. The groups are homogeneous, there is no admixture. Means for this, it is totally on one side. That is, if the person is employed, we can say that person will default. So we get entropy 0 from this formula. So we can correlate how that mixture and entropy goes together. And this is our last step to calculate the information gain of any particular attribute. We get the entropy of parent, what we calculated here, entropy of parent, that is 1, and entropy of child attribute, we minus it. So for marital status, 1 minus 1, that is 1 of parent and 1 of marital status attribute, this is 1. So 0. 0 means there is no information gain. So we can see from this table that for marital status, there is 0 information gain. Then for housing, we get little bit information. So information gained by this formula is 0.27, which is a modest type of information we can get. It all depend on the admixture of attributes in yes and no columns. And information gained for employment status is 0. We can see here for employment, we get all the information needed. So information gain is 1. We get total information, whatever is needed for this from the employment attribute. Once we know the employment status, we can almost certainly predict what will happen about default. So from this simple calculation, we can get idea about information gain, entropy, and how to calculate it. I think you got this information and will find it helpful. Thank you.